All right, we're going to go ahead and get started. Welcome to Sentiment Analysis with Jupyter Notebooks. My name is David Closter, and this is my colleague Katie Chapman, and we're going to be presenting today. We are both with Cyberinfrastructure for Digital Humanities and Creative Activities, CyberDH for short. And we're part of Research Technologies, which is part of UITS, which is here at IU. So lots of, and remember, this is a touch screen. If you want to follow along, you need to have a Carbonate account, and you can go to this link here, and that'll take you to the knowledge base, which will tell you how to get one. And if you want to access the slides, you can go to this link right here, and that way you can either follow along on your own computer or have them for later. If you missed our first two workshops, the links to the slides for both of those are right there, and you can download those and go through them. Eventually these will be up somewhere where you can actually watch online the workshops. And then today, like I said, we're talking about sentiment analysis with Jupyter Notebooks. So our presentation today, first we're gonna, what we call pregame. So we're gonna set you up on Research Desktop. We're gonna tell you a little bit about it and Python and Jupyter Notebooks and why we're using them. Then we're going to go into what sentiment analysis is, some of the pitfalls and how to avoid them, what do some of the results we get mean. We're going to briefly go through Awesome, which is another awesome tool here at IU that you can get tweets from and pull from, and they have a whole bunch of other things. And then we're going to go through the notebooks. So if I go fast, it's because I'm trying to get to the notebooks at the end there. So Research Desktop, you can access it via a ThinLink client, or like we're going to do today, going in your browser to red.uits.iu.edu. And part of the reason we use it is because it's a GUI to use the Carbonate supercomputer here at IU, which again is really useful, especially for sentiment analysis if you have a couple million tweets or something like that you're going to use. And it also has Jupyter Notebook pre-installed, so you don't have to do it. So that's very nice. Now, the reason we use Jupyter Notebooks, one, it uses multiple programming languages, including R and Python. And I know both of those kernels are already installed on the one on Research Desktop. It allows for detailed annotation of the code, which makes it a great pedagogical tool for beginners or teachers. But it's also sophisticated enough that for experienced coders, they can use it as well. And we have a few people in our group that have PhDs in computer science that use it to code. So, and Python is what we're going to be using today. Part of the reason for this is because VADER, what we're using for sentiment analysis, is only available in Python. But we also use it for all our other notebooks. It was created by Guido van Rossum and first released in 1991, so it might be older than some of you in here. It's named after Monty Python, the comedy troupe, not the snake, even though that is the emblem you always see used for it. It's beginner friendly, reads almost like English. It's versatile, again, used for text analysis, data mining, visualization, machine learning, sentiment analysis. And it makes use of packages, which is great because then you're not having to recreate the wheel. Somebody else has already made a package that does all sorts of neat stuff. For example, NLTK, which is where VADER is located, so which is what we're using today. All right, and now Katie is going to talk to you about accessing Red.
All right, so have both of you used Red before with Carbonate? No, I know you have. Okay. All right, so first we're going to go to red.uits.iu.edu in any browser that's your favorite. Once you get there, you'll log in with your IU username and passphrase and go through Duo authentication, just like you would with any IU resource. Mm-hmm. Yeah, Matt's gonna come give you a hand. And it'll take 20 to 30 minutes to set up, but hopefully by the time we get to the hands-on part, you will be able to access it. Okay, all right. And Matt can help you catch up if at some point you need to. All right. And so the next step is getting our tools and our data, which even if you've downloaded this repo before, we've made some updates, so you need to pull it down again. So inside Research Desktop, you'll need to open Firefox, which you can see the icon on the upper left. Then you'll navigate to this link, or you can just Google CyberDH text analysis, and this should be the first hit that comes up. And this is our GitHub repo that has all of our notebooks, scripts, and data in it that we'll be using today. And these are actively updated and have the notebooks for our other workshops as well. So you can access any of our materials through those. All right. I keep noticing I'm blocking links. So if you can't see past me, let me know. If you got you're where you should be. Just, yeah, Google for CyberDH text analysis in the Git. Yeah, no, that is an ad. Scroll down some more. Yeah. Yeah. Oh, there. It remembers from last time. Oh, click on that again.
Oh, change it to DH.
Oh, okay, good. Good catch, Matt. Thank you. Yeah, you'll get an email when it's available, which hopefully will be by the time we get to the hands-on part. But if not, you can at least follow along and then walk through the slides later with our on your own. And of course, you can email us if you have any questions. All right. So once you're in the repo, you're going to click clone or download, and then choose download zip. It'll keep saying downloading way past the time it's actually downloaded the file, typically. And then you will get a pop-up that says how you want to open it. Choose the first option, open with Archive Manager, and this will let us save and extract the files. So choose Open with Archive Manager, click OK. You'll get a new window. And so you'll get the extract window, click the file to select it, then choose Extract. And then we'll choose your save location, which should be your Carbonate home directory. Once you're sure you've selected home and Carbonate, click Extract, and it'll put all of the files we'll need for today in your home directory, because that's where all of the notebooks will be looking for the files. And there is one step for creating a .modules file. Since you've already made that one, you don't have to make it again. But when you go through and have the Carbon account, you want to follow these steps. You'll make a new text document, Applications Utilities Text Editor, and then you'll type in the bit of text here, module unload Python, and then load Anaconda with the specific versions of Python. And so what this does is make sure that the red environment has the exact version of Python that the notebooks need. And you'll only have to do that once. Once it's saved there, it'll be there every time you try to run the notebooks. And that one you'll save to your home directory in Carbonate as well. The first time you make the .modules file, you want to log out of Red, start a new session. Because you already had it, you don't have to do that now. And so that makes sure that it takes effect. So when you go back through these, make that file, log out, use log out, not disconnect, and then log back in. All right. And so once you have that set, you can launch Jupyter Notebooks inside Red. And we've got it under Applications, Analytics, Jupyter Notebook. And it usually takes a couple seconds or more than a couple seconds to open. But when it does, it'll open up in Firefox. And you'll see a list of everything in your home directory, including Text Analysis Master, which is where all of our files will be, because that'll be the name of that GitHub repo that we pull down. All right, any questions so far? Is anyone online? All right, and now David is going to give you an overview of sentiment analysis.
All right, and then acknowledging the Monty Python roots of Python, we will now do something completely different. So what is sentiment analysis? Well, put simply, it is the task of identifying negative and positive opinions. So if you're looking at words in a tweet and you're a computer, how would you tell? So consider this following statements. I like chocolate ice cream versus I love chocolate ice cream. Now, depending on your algorithm, words like love and hate are going to score differently. In simplistic algorithms, they're going to get a +1 or a -1, depending on if they're negative or positive. However, VADER, the algorithm we'll be using today, does take into account strength of feeling. So love scores higher than like on a range of -4 to 4. So in VADER, actually, love is rated at 3.2 and like is a 1.5. So you should have gotten a paper with 3 tweets, and you are going to go through and rate the words on a scale of -4 to 4 like VADER does. So you find words that you think would hit. Go through, find a word you think would be not neutral. So, you know, avoid the and it and is, things like that. Right, yeah, right. Chocolate doesn't hit no matter how much it brings us joy. And then we're going to walk you guys through that first tweet. And we're going to actually use, so a little cheating on that first one. Those are the only 2 words that hit in VADER. That's why we used them. All right. And again, don't worry about being right or wrong. There is no right or wrong. It is your opinion. This is just an exercise to, one, kind of give an idea of how difficult sentiment analysis really is. And also, I've never heard of a completely 100% accurate way of doing sentiment analysis, because even humans, when we read something, have a hard time determining things like sarcasm and all that if we don't know the person who's tweeting. All right, so let's compare some scores, okay? This I did based on what I had scored it at when I did that first one. I'm just curious, anybody else, did you cheat and just do what I did, or did you come up with your own? Okay. Yeah, what did you just go around the room a bit, and what did we have down here for just that first sentence? We'll just do the first. Okay. 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 Oh, that's fine. Okay. And then -1 for restrict and +2 for protect. Okay. Hey, great minds, right? Think alike. Okay. And then -2 and +1. Okay. And then Tassie, would you? -2 and +3. Okay. And then Matt, same thing. Okay. All right. So when you add those together, you get if you scored it like I did, -1 for restrict, +2 for protect, you get a 1 when you add those together. What that means though, is we are going to have to normalize our scores, okay? And the reason why is because when we do a regular, just a +1, -1 kind of scoring, we get problems like this. If you look over here, there used to be an arrow on this. There's a 1 all the way over here on 23. So we have a +23 tweet. Why? Because somebody wrote the word 1 23 times. That's a problem. The other problem is this is sentiment for Bernie Sanders, and you can obviously tell this was not written for him. It just, because we searched by the call sign and it had it in there, it pulled that. So that might also be another issue as you're going through your data. But right now we're focusing on the normalizing and why we're doing it. So to normalize a score, we're going to have to use our cross multiplying skills from grade school. So we're going to whip those back out. Some of us, it's probably a little more recent than that. So since our first score was a -1 and the highest possible score was 4, we're going to have x over 1. So 4x equals -1. So x equals a -0.25. Okay, so the same with our +2. It's 2 over 4. And we're going to do the same thing, and that gives us a 0.5. So now we calculate the average. So we're going to take -0.25 plus 0.5 over 2. That gives us 0.125. And 0.125 is then the weighted average on a scale of -1 to 1. So that's what normalizing does. It makes it so that our scale is now between -1 and 1. So it normalizes it for all of those sentences. So when we get something like the Bernie 11111 tweet, it brings it back so it's more usable and doesn't inflate our results. So some limitations of sentiment analysis. It does not consider context. So if we have an example, the death of poverty, right? We would consider that a great thing, but most are going to see death and poverty, and those are going to be negative terms. It doesn't understand sarcasm or satire. So I'm a long-suffering Chicago Bears fan, so this was my example. So might tweet, "Great job, Chicago Bears. Could you turn the ball over more?" Right? I'm being sarcastic. Doesn't pick that up. Positive and negative words can cancel each other out. All right. You tweet love, not hate. That's a positive sentiment, right? But those are going to actually cancel in a lot of dictionaries and a lot of algorithms and become a neutral tweet. And then there's dictionary bias. We have run into dictionaries where the term white is positive and the term black is negative, which when we then looked at tweets from the Charlottesville demonstrations, that was really problematic. So we're going to do a little, all right, is this tweet positive or negative? Cute figures found after the breakout of the hashtag coronavirus. Many citizens wear inflatable dolls instead of protective suits to protect them. An astronaut, a cute bear, and even a Christmas tree are being seen on the street. These figures partly relax the tension. You can see the person there on a bike and a cute little teddy bear outfit, right? So is this positive or negative? We have another one. This is helpful information, right? So we might consider this positive. However, it is talking about a pandemic. It's talking about how the disease spreads. So, you know, some of these are really hard to, even for humans. I might say, oh, this is really good. You might say, no, this is really negative. So now Katie's going to talk to you about some of the pitfalls and how to avoid them.
All right, so our example in this case is looking at sentiment analysis of the first 100 days President Trump was in office using Twitter. And so taking that as a starter for our data set, the idea was to explore a few different algorithms and see how the results turned out from the different approaches. So, but this really wound up being a deep dive into the origins and structures of dictionaries and actually reading through the dictionaries themselves, which are the word lists that the sentiment scores are connected to in each of these dictionaries, to see how the dictionaries are biased, either intentionally or unintentionally, which then, of course, affects your results pretty significantly. So the two sets we'll look at today, the first 100 days of Trump's presidency and Charlottesville in August 2017. If you remember, it was the white supremacist demonstration that got violent. And so what it was kind of intended as a, let's run this into analysis, see how this works, really turned out to be a really informative foray into the actual algorithms, the visualizations, and how to best work with these. I touched it with 2 fingers. This one. We only recently got a touch wall. We're still learning. Although he did specifically warn me about only 1 finger. 2 makes it do weird things just a few minutes ago. All right, so outcomes from these approaches. Having a specific topic, looking at these 2 specific data sets was essential to how we noticed details that let us identify the problems that we did find in these dictionaries and system analysis approaches and some more broad issues. And so the fact that we had these meant that instead of just going in and saying, we want to look at the dictionaries, this kind of focused how we learned about the dictionaries. If we had not been looking at the issues of racism in Charlottesville, some of those things would not have come up that we did find. And so throughout this process, we were looking at the distinction between and the interplay of how the algorithms worked, what the visualizations showed and how they showed different things, what was most effective. Of course, looking at the data that's being analyzed, Twitter data has its own specific considerations when you're looking at that compared to other types of documents. And then, of course, the dictionaries themselves, the supporting data, what was coming from them and how did that affect our results. The cable touched it. Yeah, but I hadn't touched it yet. The cable touched it. I'm going to stand further away from the wall. Trump's first 100 days. So what we did, we scraped 244,803 tweets between January 20th and April 29th, his first 100 days in office, that mentioned President Trump. At this point, we were using an open source program called Tags. Since then, things have changed with how access to Twitter APIs work, and so now we rely on Awesome, which David's going to go over later, which is also available to the wider IU audience, so it's a good resource for folks in the IU campuses. And of course, we chose Twitter because that's Trump's chosen medium of communication. So his critics and his supporters are also there, and so it's a really good place to do some analysis on Trump's policies. And so the idea was to not only see what was there, run some analysis, but then also get a better understanding of the tools you were using while we were doing this. And so this is what a simple algorithm looking at positive and negative sentiment within these body of tweets was. So first major issue, the dictionary had Trump in there as positive. So the person we're looking at to name is in there. And people are tweeting things like this. Trump, 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 Trump. And so obviously our first positive result, 138,420 appearances of Trump. So obviously, if you're going to do analysis on this body of data, this is not going to work. And as David mentioned, depending on your topic, the word right isn't as positive. And so if you're thinking about politics, where that has a much more complex meaning, you have to think about that. Because if you would just run this and gone with it, I would have skewed what you were looking at pretty significantly. And so actually, if you look up Trump in the dictionary, it does support the positive. Like in Bridge, Trump's is a good thing. We also have an informal dated definition of Trump, which means a helpful or admirable person. So it's a former usage of that word. And so like we can see where they got the positive from, but for our data set, that was not going to work, obviously. So we get to our top negative words, this time using VADER, this analysis dictionary that David's mentioned already. And so no makes sense, is one of our most common negative words. And then we've got ban, fake, war. It does not screen out naughty words, so sorry if you're offended by anything that shows up in this. But so we get a lot of different words, which I think all here, these are all negative. There's not really the same problematic words that are really going to throw off your data set, like we saw with those ones coming out of the simple algorithm. So this is pretty good. Positive words from VADER, which does not have Trump in it as a positive. So like, want, one. VADER does take into consideration the text and Twitter abbreviations, which can be a little complicated because sometimes those meanings change. So GT means good try. I thought someone was about to correct me. The meaning, perhaps the meaning had changed since this morning, which is possible. Yeah. Yeah, so for really anything that's social media. And so they try to incorporate that. It accounts for emojis as well. And so it's really the best resource when you're looking at social media because it is thinking about these sorts of things. It does mean you have to look up a lot of Twitter speak things because I didn't know what half these things were. And single character ones are really complicated because those usually can have multiple options. Yeah. Yeah, because L isn't there as positive, so we think it means laugh, but I feel like it should have to have at least 2 characters to be, even if something in Twitter speak. Yes. Yeah, standalone L can be laugh, or it can represent loss. Usually if it's loss, it was capitalized. Yeah. The internet's a complicated place. All right, so then looking at the Charlottesville tweets. So again, we scraped tweets related to the Charlottesville incidents, which is really where the problems in some of the other dictionaries became very apparent. So white is ranked as a positive word, and the process that we were looking at here. MAGA is complicated because it's being used both positively and negatively and sarcastically. Trump supporters are using it in a genuine and positive way. Critics have adopted this and use it in hashtags as part of their criticism, or use it very sarcastically. So that is a very difficult one to look at with straight up and sentiment analysis. We see things that are coming up a lot. Real Donald Trump, which is his handle. A few other names that come up. Fire Bannon was a hashtag that was going on at the time. And so we find that throughout, and VADER does include the hashtags. So we get those that come out. Not surprisingly, other things that were really common in the tweets. Racism, Nazi, fake news, hate. And then we have a word cloud representing those frequencies to kind of help you parse that data. You can see like how frequent these are. We've got this cluster in the middle, white, MAGA, and people. Bannon's right off to the side there. And so depending on your data set, you have to take a lot of things into consideration when you're making your choices and your prep before you do your analysis, or run an initial analysis, look at your results, see what your positive and negative words are, and then see how you need to adjust. And now David's going to take you through what these results mean.
Mic handoff and okay. I'll try to stay out of your way. So how does today's script work? Actually, it might work better if I'm over here. So it's not just a +1 for positive words and a negative or a -1 for negative words, but each word is scored on a positive, negative scale or valence and given a final compound score. So the other thing is it considers emojis. If a word is in all caps, it emphasizes them. the positivity or negativity of the word, and punctuation. So if you have that many exclamation points after, it's going to enhance the score as well. It considers common n-grams like not good, nor funny, kind of good, which helps a lot. They used Amazon's Mechanical Turk to score the words, and they got 10 people, and they all scored each word, and then they came up with, including neutral 0, and then these were averaged together to get a final score for that word. It gives each tweet a separate positive, neutral, negative score, and those scores are ratios, so it should add up to 1. So it's basically what percentage of the sentence or the tweet falls in the positive, the neutral, the negative category. The compound score then sums the valence scores of each word in the lexicon and then adjusts it according to their rules, which there's a whole paper on. And then it normalizes it to be between -1 and +1, as we showed you in the example before. Okay, screen. Okay. Okay. So here's some of our VADER results from Trump's first 100 days. You can see if you just group them as negative, positive, and neutral. Our experience is that neutral, there tend to be more neutral tweets, mainly just because you get a lot of tweets that are, don't hit. They don't have words that hit in the dictionary. So if you have something like, hey, check out this link to this video, and the video might be negative or positive, but VADER doesn't consider the videos. So, and then you can see this is when we actually space it out over the scores. So anything, so -1 is actually anything that's that or below until it gets to -9, and then that's that or below. And then you can see what percentage makes up those scores. So again, over half are neutral, but you also then get the mean. So overall, we have mostly -0.03. And again, VADER, while we found it better, is still not perfect. One of our examples, again, we found this when we did it on Charlottesville. The word supremacist is a positive 0.5. However, apparently if you have more than 1, it's negative, because you see supremacists is -1. So, but this was problematic. And you can also see it has a slightly higher standard deviation than some of the other ones. Their cutoff for VADER is 2.5. So this just made it, but it tells you that this one also is probably even problematic for their, and you can see the graders right here, they were all over the place. So we're going to try some of this on the coronavirus. So again, even though the coronavirus is not a good thing, you can see a majority of the tweets are neutral. And in reading these tweets, it is because a lot of them are like, hey, World Health Organization just announced such and such. Nothing hits, right? We have a few positive tweets. Part of this is because and we'll look at a timeline here in a minute, we get tweets that say, hey, this many people tested positive for coronavirus. Well, positive is a hit word, right? So it's, if that's the only one it hits, then it's going to say that's a negative, that's a positive tweet. So some of the top negative words, we have no, infected, emergency, death, die. Again, nothing I would look at and say, oh, this is a problem, right? That I would expect. Positive words, though, we get, haha, novel, because it's the novel coronavirus. And so that hits. So that's going to be a problem, right? L, I went and looked. I'm like, okay, why are people laughing? They're not. Because this is international, there's a whole lot of non-English tweets, and VADER removes that apostrophe between the something. And so the L stands alone then. So again, that's another issue, right? But this is where you have to go back and read your data and actually read it with your eyes. Not all of it, if you have like millions of tweets, but we always try to have a rule of about 1,000, read about 1,000 tweets just to see. And then, ha, I was like, well, who's laughing? Again, it wasn't that. It was because it's international, and ha is a form of to have in Spanish. And that was popping up a lot. So again, these are problematic. Yeah, I believe that does hit on VADER, but it was, I mean, they weren't talking about how many negative results there were. Yeah. 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 Because people are only interested in how many people actually have it. So this is our timeline. And to give you an idea, and you'll see another timeline from Awesome later that tells you how often the hashtag coronavirus was used. So the reason this is all over the place is because some of these days, I started on the 31st because that was the day that China alerted the World Health Organization that they might have a problem. But there's only about, when we pulled these from Awesome, some of these only have about 3 or 4 tweets for that day because it hadn't quite taken off yet. So that's why you're seeing this fluctuation here. Around the 7th to about the 10th is when you do start having people, this many people have tested positive. And so positive is hitting and things like that. And then when you get right around here to 10th or 11th is when the first person died. And that got tweeted, okay? And so then this spike though here is jumping up because the World Health Organization got the gene sequencing of the virus from China and was thanking them, and people retweeted that over and over and over again. So we had thank you, China, and that kind of thing happening all over the place. So, and then you can see there's some other ups and downs here. I want to say around here, this down is where the case, first case in Thailand. So this is the first case outside of China. And so that started getting tweeted. And then around here, when we see another decline, I think is when the first case in Japan. So then we have the second person outside of China that has tested. And then you can see it spikes here and then all of a sudden just plummets. Well, right here, we have 2 things that happened. One, first case in the United States was announced, and the first suspected case in Australia. So now we suddenly have English-speaking countries who are mostly use Twitter more than a lot of China and that area. So that's where we suddenly have this, and you're going to see a correlation in another one of these graphs in a little bit. So takeaways, be open to exploration. So know your data, like we said, read a good set. We do about 1,000 tweets when we do Twitter. Have some ideas of what you expect to see, so don't go into it blind. But be open to what your analysis tell you. Be aware of biases, as we talked about. Some of the, and a lot of them are unintended, but just be aware that they're there. And some of these tools are to help you find those because they're not always readily evident. And these biases can be in your data, they can be in your dictionary, your algorithm, visualizations. Know what's under the hood. So again, know how it works. This is part of the reason we've steered away a bit from the machine learning because it's not always clear what's going on in the background. They don't always explain it as well. Whereas with VADER, we found it's a lot easier. I mean, they're pretty upfront about how this is processing, what this is doing, and how it works. So that also makes it easier to make modifications. So, and then document your methods. So if you do make modifications, what words did we add to VADER and why? What words did we remove from VADER and why? And then, always be willing to share your data. So now we're going to talk a little bit about Awesome. When we've done that, we've just gotten 10 people and gave them a list of words and said, hey, between -4 and 4, give us a score. And a lot of times we tell them in the context of, because that otherwise they can't really do it correctly, So when we did it, was we pulled tweets on North Korea to see, because this was around the time right before Trump was going to meet with Kim Jong-un for the first time. And so we basically said in the context of North Korea, rate these words, and found 10 people to score them for us. And then we went and basically did the same math that VADER does and plugged it in. So So Awesome, though, is where we've pulled a lot of our tweets, and it's a great tool. So if you go to awesome.iuni.iu.edu, you'll see they have all these tools here. One of them is called Fakey. So it's a nice little game you can play to see how well you recognize Twitter bots, whether something is a clickbait site or a legitimate news source. So you can say I already ran it, and apparently 78%, so I probably should stay off Twitter. Apparently I believe fake news a little too much. This is actually from the midterm elections back in 2018, and it's still up. So I actually went and looked a couple days ago, and this exact thing is still there. So my guess is once we have the next one, it'll go for the next primaries or the next election. They'll update it. But this basically is nice because it does give you a percentage of tweets and which ones are likely bots, and kind of a fun one. So this is the other timeline I was telling you about. So you can see this is actually the percentage of tweets that contain that hashtag. You see how low it is starting on the 30th of December, hardly, and then right here, right before the 20th, when Australia and the US are finally have people that might have it, it skyrockets. Tag, yeah. Well, it's Twitter's banned in China.
Well, so China is not. But
right.
But I'm saying South Korea, Japan.
Right. Yeah. It's not that they're not using it, but it's using that English hashtag too. But well, that as well as I think you see, I think people here start to care more too. Once it actually was at their doorstep. So now we're going to actually get into the notebooks. All right, and so Katie is going to take you briefly through. This is actually a results one. So this is that one that showed all the words. And we're just going to show you the results very quickly. And then we're going to spend more time on the actual one that's actually running VADER and getting you the sentiment analysis results. So.
Right. And so to access the notebooks, remember earlier we launched Jupyter Notebooks inside Red. And so you'll go back to that Firefox tab and open Text Analysis Master. And then you'll see inside that we've got all of our notebooks listed. You can see that here. So then you'll want to pick VADER Sentiment Analysis Notebooks. And so these are the ones that we are looking at today. And I'm just going to give you a quick overview of the word results for positive, negative words. And then, like David said, he's going to focus on the sentiment analysis one with you. And this is just an outline, and these slides, or in the slides you have access to as well, of what each of these notebooks does. So the first part of this is the data, pulls in the data, runs all of the processes needed to get a CSV file that we can then use to look at our positive and negative words in our results notebook, which goes through these steps to pull in the CSV from the previous notebook, reads in those positive, negative words, and plots them in the visualizations that we come up with here. I would use that mouse. All right, and so the results notebook works like all of our other notebooks. If you come to our previous ones, you've seen the basic structure. It sets up first our Python environment, which each of the notebooks does, imports packages that are needed for each of the scripts, sets our file paths, which for here is pointing to the clean data sets that we have in the data set for this repo. If you're using it on your own, this is where you would change it. Then it brings in positive words from that CSV, and you can see just a sample of those here. This is run on the coronavirus set. I'm not sure where I was going with that word, but it was not coronavirus. And you can see from the other results like protect, united, please. And then it brings in our negative words, which here we've just got a quick sampling. Horror, apocalyptic, no, emergency, lazy, risk, illness, infected, die, and strain. And here's something where there's customizations. If you look at the second and third tweets in the handout that we gave you earlier, are there some words that what are some of the words that you picked to rank in there? Like what did you pick as something that would hit for sentiment? Death, yes, that's a good one. That's already in there, yeah. Other things that you think would be ranked or would be important to include? Outbreak. And that is not in the existing one. And so that's where you would want to look at your results, because I would think that that would be in like top negative words, right? Right. And so this is where this is really useful. See what's hitting, go to your and pandemic is not in there as well. And so this is where knowing your data, knowing your dictionary really comes in handy. And so same with the third one, rejected would hit as negative, and fears. Ill is in there, and so that would hit as well. But this is where going through carefully, reading those tweets, reading the dictionaries is really going to help the accuracy of your data. So then at the end, it plots them. And you can change different settings here, depending on the DPI you want, colors. But here's our top 25 positive words from VADER. And like David said, novel. So we'd probably want to modify how that was being treated since it's got a different meaning here. Same for our negative words. You can change the specific settings. It'll output this as an image file for you. And then you can review. Horror and apocalyptic are almost appearing with equal frequency, which I find interesting. Yes, looking at this, you find a lot of the crazy things people say on the internet. I've been reading through every day the hashtags for coronavirus that have been coming up, and it's getting worse and worse. There are a lot of conspiracy theories, and people are saying some very odd things. So depending on your data set, you'll see things that maybe don't make sense. But again, if you go read through, you'll see they're being used in a strange context. There are a lot of conspiracies that it's, you know, an intent, like a biological attack aimed at the senior population. That was one I saw today. So again, knowing your data, knowing your dictionaries is the really important thing to think about this. And these will help you get you there. They'll help you see what you're working with. And then you can move on and start doing the sentiment analysis itself. And David is going to take you through that notebook.
Yes. So as we said, this is the results one. So there was a data one before this that you would do that will collect your data and it will save it in an output file. That way you don't always have to run all through that again. And you can, if all you're wanting to do is make changes to your output, then you can do that. Same now with the VADER sentiment data. We're going to first do one that pulls in our data and saves it somewhere, and then we can revert to our results one. That way, once we've got the data we want, we don't have to keep going through and making those changes and running it again. As I've said before, if you're new to Jupyter Notebooks, there's 3 ways to run them. You go to Cell, and you can click Run All. So if you see that right down there, Run All. Or you can highlight the cell of code you want to run and click the play button. Or my preferred way is to highlight the cell I'm on and hit Shift Return. And you can just do that all the way through the notebook. And that helps too, especially as you're editing, because then you can just run that cell and see if your edit fixed your error or something like that. But as Katie, when she went through it, said, I'm going to skim through some of these because they're in all of them if you've been here before. So again, pulls in our Python environment. We import our packages. Here's where you're going to make some changes. These are the variables. So our source is our file. So this one, we're just looking at tweets from January 1st to the 21st. Some of the examples in the slides were from December 31st all the way to February 8th. So there's quite a bit more in there. We did this because that one will take a while longer to run, and to make it so it doesn't do that, if you're actually wanting to run this in the workshop, it'll run through. And we have some things here. So you guys have talked about, there's problems with some of the words, right? So we've actually added ways where you can remove words. So here we've decided, we want to remove novel and ha and L. And looking at that, I went through the tweets and it didn't mean good try. It actually looked like it was part of a call to an image link. So somehow that got in there. So I'm like, oh, I don't want that. And so if I want to remove words, I'm going to set that to true. And then I'm going to add the words I want to remove there. If I want to add some words, this one's a little trickier because this is where you have to come up with a score. And these scores, I'm going to be honest, were made up because I got this working yesterday. So I had to come up with something really quick. But if you ever do this, you are going to want to do and follow the steps VADER did. Find 10 people, have them score it, then go through and do the math. And then you just have to add the word and that averaged score of those 10 people there. And it will automatically include that then in the scoring. So the other ones I think you guys can figure out a bit. I just wanted to focus on those really important ones there. And then our paths. So these are going to be file paths that lead to our data and to different output. So the data clean one down there. This just unzip files, which is important because a lot of our data, GitHub has a 25 megabyte limit in uploading, so we have to zip it in order to fit it all and upload it. So this will go through and unzip those files for you, so you don't have to go into our data folder and do it manually. And then this will read in either the file type CSV or JSON. Right now, all our data is only in JSON. We added the ability for CSV because we have had people come to us that their data they got from somewhere else and that data was only in CSV format. And it's happened often enough that we decided we needed to make it available. So, and here we're turning our read in tweets into a data frame, which is what VADER is going to go through and then read and score. We have to create a dictionary here. So we're basically creating a dictionary where there's something labeled -1 all the way to +1 in the other direction. And now we're shortening so we don't have to type in sentiment intensity analyzer and possibly misspell things. So we're just shortening it to VADER. And here is where we're removing our words and adding words. And luckily, VADER has a way of doing it that they've included. So I'm not going to tell you how long it took me to figure that out. And then here we're actually running VADER, as well as getting a little bit of other data. We have some scores, totals, number of tweets, total squared. This is all stuff we're pulling so we can get things like the mean and the standard deviation and all that later. But this is what's now running VADER, and we get a printout of our results so you can see how many tweets scored as -0.9, -0.8, and all the way up. And now it's exporting that data into, I told you about before, the folder that contains the output. So now if you're happy with, you think you're happy with what you got, now you only want to make changes to the output. Again, pulling in our environment, importing packages, file paths. We're loading the data that we have saved, and I just printed it out once, just you want to verify that it's the same as what we got over in the other one. And now we're going to calculate our mean and our standard deviation. This is just outputting a file of the raw data, so the raw scores and the mean and the standard deviation in a CSV format, in case you want it. And now, as with the other ones, we have variables to change the graph a bit. So you can change the name of the output file. So it's going to save a PNG image of your bar graph. And then the other stuff, DPI, color of the bars, and a lot of it is just the size of the graph, and the title you might want to change if you're not looking at the coronavirus. And then our output is below, and it gives you a nice, you can see how negative the average actually is compared to some of the other ones, -0.15, standard deviation of 0.41, number of tweets is 14,000, and this is from January 1st to the 21st, 2020. So you now have a nice bar graph to show your results that you can now analyze and do a more in-depth analysis of. So are there any questions, comments? I did not include that. I just did this, but I can. Again, just doing the positive removing is a lot easier because you don't have to put in the score. It just then no longer considers it. The only thing I would say is something like that we don't have in this, where you might have to actually go into the lexicon itself, is if you want to keep a word but change the score. So like supremacist, right? We might actually want to keep that for Charlottesville because it's a negative term and they scored it positive. So we might give that word to some 10 people and say, in thinking of, Charlottesville, and you heard supremacist, between -4 and 4, how positive or negative would you rank this? And then change the score to that. And you can actually go into the lexicon and change scores if you need to. So that's what VADER used. They used 10. So keeping it to what they did just so it sticks with their methodology. That's why we did 10, because, yeah.
So my one concern with there is we also brought up that it was done on Amazon. Mechanical Turk is a service that people go, it's like a gigging service. You can accept jobs, and you don't know that the people who are rating these words are native English speakers, and in fact, sort of there have been papers written about the fact even that it's called Mechanical Turk and the overtones of that. And so some of this, like the supremacists ranking positive and then supremacists ranking negative, could just be different people who were assigned different portions of the dictionary, and then looking at dictionary definitions where the root word supreme is positive, but then somehow someone else looked at context. And so again, not necessarily a consistent set of 10 people. And I think that that's also possibly a problem with the package.
So that being said, this is still, I think, one of the best ones we found. So, and as I said before, there is no 100% accurate sentiment analysis, at least not that I have found. If somebody knows about one, please let me know. Yeah. As far as I know, they were just given words. At least my understanding of the paper when I read it was they were just given a list of words. Because I think it's hard to know what context a word's going to be used in. That's why when we've changed things, we've added context, like in the context of North Korea, in the context of Charlottesville, because the context now does change the valence of that word. So that's where we talk about like knowing your data set, what the context of these tweets. So coronavirus, the word positive is not a good thing. In any other context, yes, it is. So that might be something where then we would give that word to 10 people and be like, in the context of somebody testing positive for the coronavirus, how would you rank the word positive on -4 to 4? I'm going to guess you're going to get a lot of -4s. Maybe some -3s. Some people don't mind being sick. Yeah. So the way it usually works, at least my understanding in the paper and in the code, is if you have a positive word, good, but you have not in front of it, it's going to actually flip that good score to. So it's going to basically add a negative in front of it. Mm-hmm. Yeah. So yeah. Like this is no good, then it's going to flip good. There's other ones where it doesn't flip it. It just there's enhancers as well. So like extremely good, it's going to enhance. Because extremely is kind of could be extremely bad as well. So then they have a set amount that it's going to buff or increase or decrease the score. All right, any other questions? Do we have any questions online? Was anybody online? Okay. Okay, well, thank you again for being here. I'm going to put up our final page here of. I hit the last slide that I'm trying to. So.
Also, our previous series will be available. There's a YouTube playlist for this series, and so they've been putting those up. There's a bit of lag for the videos to be available, but the slides you can access now. Yeah. And the slides you access there will be formatted for your screen. The correct aspect ratio shows you don't have to peer at things very tiny, so you don't have to come here and use the slides to be able to read them.
Okay. Mm-hmm.
You pulled out the dictionary and you looked at how it scores specific words.
Mm-hmm.
But in order to understand the impact of the specific word, it's not like that's done within VADER's package. They don't give you the tools for that. You had to kind of reconstruct it.
Yeah. Right. Yeah. I mean, there's a file. It's just vaderlexicon.txt.
Do you know the steps that they undertake, like lowercase and
if you go to the NLTK package and look it up in there, it has their code in there. And so they do some lower casing, but I think it's usually after they've already looked at if something has all caps, because that enhances scores as well. But then if you look at their dictionary, all the words and everything are lowercased. So at that point, then, yeah, and the standard deviation as well. Because if anything, again, if the standard deviation was higher than 2.5, they didn't include it. If even after giving it to 10 people, it averaged out to 0, they didn't include it. So these are all only words that had a valence. So this might not necessarily be the only words that they actually had people scoring. It's just some of them, either the standard deviation was too high or, but I haven't found a list of what those were. Mm-hmm. Mm-hmm. Yeah. Yeah. And I have a copy of it too, so if you want to email, you can email and I can. Okay. So yeah, so yeah. Sent it to them too. So I've been spreading the paper around, sending it to people. Yeah. Yeah, there's some words actually that they have the misspelling because the misspelling is common enough that they actually have included misspellings of some of the words. So yeah, so it's just ones that are commonly misspelled, but I thought that was actually kind of nice. Like, oh. Yeah, yeah. Well, okay, yeah. Somebody spelled it with 2 N's, right, or something, Corona? Oh, right. Mm-hmm. Yeah. Both problems. They're commenting on both problems. So yeah, and in the VADER paper, you'll read too that they compared it, especially on social media. VADER actually scored higher than the machine learning. There were other ones where I don't think they didn't score very low. They were usually at least second or third, even in other platforms. And I've used VADER and helped somebody use it on speeches from Martin Luther King Jr. and Malcolm X because they wanted to do sentiment analysis on those. So we actually did a score just by sentence, like treat each sentence as a tweet and then average the entire speech. So, and he starts off that way. That was what she was looking at. She was saying that they eventually even out and become that Martin Luther King Jr. became more radical towards the end, and Malcolm X actually mellowed, and that actually showed in the sentiment. They started to meet more towards the middle. So, so that was interesting. Yeah. But anyway, so I thought that was an interesting use of it too. But again, it is built specifically for social media. So use it on other things with a grain of salt. But all right, well, thank you all for coming. And again, if you have other questions or a project you would like us to help with, please email. Or if we already have a project that we're doing with you, still email. Yeah. All right, thank you all.